Alright, welcome to my short presentation about my thesis, Interactive Visualization of Douglas Fir Forest Growth Using 3PG. My mentor was Dr. Mike Bailey, and my committee was made up of Dr. Yue Zhang and Dr. Raphael D'Amicis. So, my project really has two parts. The first part is the simulation, which is basically a reproduction of the existing forest model 3PG, which I'll explain more in a bit, in C and C++, which produces a range of numerical outputs describing a forest, and the visualization, which takes those outputs and creates a 3D visualization of the forest in question. And to do that, I used OpenGL, Glut, and the user interface package GLUI. So a bit more on 3PG. It's a well-trusted and often used forest model. The original paper was published by Drs. Landsberg and Dr. Waring in 1997. There have been numerous expansions since then, re-implementing it in various languages and packages. And most notable for me was Dr. Forrester and Dr. Tang's 2015 paper, generally just called 3PG Mix. The important thing about that one is that they have very good documentation for it and lots of lists of equations and stuff which I could use to create my own implementation. And the goals of creating this visualization of 3PG was first to confirm the function of the model, and then next to have this visualization maybe let the user have some more new insights that they wouldn't otherwise get from just plain numerical outputs. Because the notable thing about creating this visualization is that in all the implementations of 3PG, I have not yet found one that does a 3D visualization of the forest itself. While many produce graphs and such, to my knowledge, this is the first implementation of 3PG that shows the forest in 3 dimensions. So in other words, confirm the expected and discover the unexpected. Here's sort of a general flow of the program. Over here on the left, you're seeing all the input parameters come in, which I like to describe as site data, stand data, and species data. Species data being empirical information about the species and how it reacts to different conditions. Stand data being basically the initial conditions of your stand, and site data being mostly weather and climate data. Then the user can make changes to all of this, and all of those input parameters go into the simulation, which produces a set of numerical outputs that I use to just produce some normal numerical output as well as my visualization. So here's kind of an overview of what that simulation looks like. So our main goals are kind of highlighted in blue here. The first two being gross primary production and net primary production, which basically tells you per month, this operates on a monthly time step, how much new biomass we're getting for our forest, how much new forest do we have. And this is calculated using this CQE, which is canopy quantum efficiency, PAR, which is photosynthetically active radiation, and then a bunch of modifiers. And this is basically taking into account how much solar radiation is falling on the stand, and how efficient is the stand at turning that solar radiation into actual biomass. So once we have that new biomass, we want to partition it into which part of the tree it's going to. And it can go to either the roots, the stem, which includes the trunk and branches, and the foliage, which in the case of Douglas firs is the needles. From there we can calculate diameter breast height, which is an important measurement in forestry, that is the diameter of the tree trunk at 1.4 meters off the ground. And from there we can use a lot of empirical parameters to calculate a lot of other descriptive parameters about the trees in the stand. Here's all those outputs. And here's basically what my simulation ends up looking like. Here's how the outputs make the trees. I draw it in 2 sections, the trunk and the crown. So the crown is dictated by the crown diameter and the live crown length, which is basically how long is the live foliage part of the tree. And then the trunk is drawn using tree height and diameter breast height. So there's 2 versions. There's a simple version, which is requires a lot less computing power and can also draw a full hectare of trees. A hectare is about 2.5 acres for reference. And then this OBJ version uses a 3D model for the crown of the tree and can draw around 30 to 60 trees depending on your hardware, and looks quite a bit better, but is more taxing on your system. Then variance. I did some research into how much variance there are in these output parameters in real life and used that to inspire how much variance I added into my visualization. So as you can see on the left, without any variance it looks a little funny and you start to see kind of these lines and things. And with variance it just looks a lot more natural and less distracting. Kind of the same thing with the skybox. The black void and the blue background are just a bit distracting and unrealistic, so I added this skybox to kind of just let the background fade away and not distract from the main point of the visualization. Then a short little demo. So here's what it looks like. You can change a lot of things on these sliders over here and then see the results in the stand. So I'll skip ahead a bit to where I'm doing it on the OBJ model version. Same thing here, I'm going to be changing fertility rating, which is a nutrition parameter. More nutrition makes healthier trees. That's sort of an example of confirming the expected. And then over here, kind of some examples of maybe discovering the unexpected are increasing the maximum monthly temperature by 5 degrees Celsius and still seeing the trees grow, which means that we're not yet at their perfect optimum temperature, which I thought was quite interesting to see, especially in relation to predicted climate change scenarios. Alright, yeah, so that's pretty much how it works. You can, up here in this top box here, you can enter in your stand data and sort of some initial values and then change stuff around in here to your heart's content. There's a few other options for which specific equation options. Right here we have which display mode you want to use, and then this generate full run button will generate all of the month's outputs from 0 to whatever you last set t to in a convenient file format. And to finish it all off, here is all of the references. These are the same that are in my thesis document. Alright, and thank you so much for watching.